Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So today, we're going to be continuing the code that we were writing yesterday, which was primarily about fractal flames, iterated function systems, all of this kind of stuff. So if you're here for the first time, you weren't here yesterday, let's talk about what we were doing, why it's interesting, and all of that kind of stuff by first talking about iterated function systems with this visualization here. So here we have 3 points, A, B, and C. And what we're going to do is we're going to generate 3 functions, which will take in some sort of point, and then also output the point that is the midpoint between A, B, and C, and the point that you're providing. So, for example, if we have 3 additional points, D, E, and F, and all the children of D will be colored red, all the children of E will be colored green, all the children of F will be colored blue. We can basically say that each of these new points will generate a child that moves halfway towards A, halfway towards B, and halfway towards C. All of those children will then generate more children, who will then generate more children, and more children, and more children, and more children, until eventually you start to see the Sierpinski triangle visualization that you would expect to see. Now, in this case, the Sierpinski triangle is essentially an attractor. That is to say, it attracts all points to that triangular, to this weird triangle within triangle structure. And yeah, this is kind of the visualization we did yesterday. So what I'm going to do now is I'm going to put this visualization in the upper left-hand corner. And I'm actually, let me put that on loop first. And we'll talk about what we're going to do today. So we're going to have this looping in the upper corner. And yeah, Eloxor, hey, Emerus, hey, I hope you guys are all having a wonderful day. And anyone who might be lurking in chat, hey, thanks for being here. I hope you guys are all doing well. Let me move this down really quick. Yep, that should be fine. Okay, and also let me lower the volume here just a little bit on my end. I don't think it'll lower the volume on your end. Okay, I really need keybinds to set my volume, but whatever, it doesn't matter. So let me open up Zernal PP. Zernal PP, and let's talk about what we did yesterday and what we're gonna do today. So again, I'm pretty excited to get this done. Hey Cropep, how are you? Let's move this over there, move that over there, and let's talk about it. Psychode, hey, how are you? Okay, so what did we do yesterday? So yesterday we created a new package that was Flamify. The name's dumb, but that's what I called it. You guys are just gonna have to deal with it. And what we did yesterday is we, did a chaos game. This was relatively straightforward. It's pretty easy to do. 2, we then projected the chaos game onto an image, imagified, sure. And then 3, what we did is we added color and point structs, which are necessary for the next bit, which will be actually adding in a flame. So now we're going to start attacking the fractal flame nature. Yeah, rasterize is probably the correct word there. Let's put that one in there. Rasterize. That's fine. Okay, so what is a fractal flame? Let's go over here and let's look for fractal flame. And let's go to images. So a fractal flame is a combination of different iterated function fractals. And yeah, it just looks something like this. We're going to be updating that we're going to be working with things like this in the future. Like hopefully on today's stream, we'll get like a basic flame going. And then maybe tomorrow and the next day, we'll start adding in all of the details that we need. Like, how do I put this? Like, motion blur and stuff like that. The image that we're working with right now, let's go ahead and cd into projects, Flamify, ls here, remove check.jpg. Literally all we have. Again, we've already written this code, but yesterday when we went back to look at that code, quite frankly, I couldn't get the code to work. The code was in need of a real big refactor, so we just kind of decided, screw it, let's just redo the entire code base. So here's what we have right now. Literally just a Sierpinski triangle that is in the appropriate direction, with each individual point colored at random. That's all we have. It's just an image with a Sierpinski triangle inside of it. So we don't have much right now, but we'll get there, Did that just... Okay, thanks for, okay, whatever. It kind of broke. Is Julie... Wait, let me see here. Working back on forward Euler method, all values within a threshold. Nice. Yeah, thanks for doing that, by the way. Is Julian not backwards compatible? It is backwards compatible, but my code was just awful. I wrote bad code. That's just what it was. You know, I was too busy at the time, and I do this quite frequently. You know, like I kind of, a few months ago, I really wanted to get this code out as soon as I could. And because I was rushing to get the code out, I wrote some pretty bad code. So yeah, different formula would be different flames. But actually what we're gonna wanna do here is not necessarily different formula, so much as we want, well, we're gonna have to do a bunch of different things, right? So what I'm actually gonna do is I'm gonna open up the paper and we're gonna go through it and we're just gonna start talking about the things that we still need to do. So cd into projects, what am I doing? Flamify, ls? Oh, the paper's in another directory. Let me just go ahead and cp, I think it's actually gonna be here, Simuleos fractal, and then I believe the PDF is in here. Yeah, flame draves.pdf here. And let me just open that up with, I guess Zernal will also open this up. Flame draves.pdf. Okay, so here's our PDF. It's kind of not quite, let's move this over here maybe. Well, let's keep it over here in the corner. And let me move in. I think this is still kind of big enough that you can read it. Let me move it over a little bit, maybe a bit bigger. Okay. So this is a paper that I typically go through when I'm learning, when I'm doing fractal flame stuff. It's relatively easy to read. Let me go ahead and give you guys a link to that as well. Literally, if you Google fractal flame, you will find this paper. It's not particularly hard to find. Here it is, right here. There you go. Okay. So if you guys want to, you can, oh, forward Euler method in coconut. There we go. I just saw that PR go in. Nice. Unfortunately, I think like you're the only one that knows coconut. So I don't know. I don't think we can actually do anything. Like this is a problem with the algorithm archive. We need more people to review. And the only way we get more people to review is if the project gets bigger. And the only way the project gets bigger is if I make content. But if I make content, then we have, it's a circular argument that just, it's hard. Like, yeah, it's hard. It's still draft PR. Oh, fair enough. Okay. So let's talk about it. So the fractal flame algorithm, right? They do an overview. They talk about iterated function systems, which we've already talked about. And then they basically say, yeah, so we have, here's where things get a little bit different. So actually, let's read through their definition of classic iterated function systems. And let's just kind of, you know, work through it one step at a time. So that might be what we do today. We just slowly but surely go through and you know, just start reading the paper, implementing all the bits in the paper and getting that in code. You know, we got to take it one step at a time anyway. Is all Python valid in Coconut? Well, there's Berquist that does Coconut reviews, but that's just the two of us basically. Yeah, Berquist like really puts in a lot of work, and I'm really happy that he's helping out, you know. Let me open up a new terminal to cover this other terminal that I have that I opened up. Anyway, you know how it goes. Let me just move this up here and move this down there. Oh, 1 second. Move this down one. CD into projects, Flamify, great. Okay. So they have classic iterated function systems. A two-dimensional iterated function system is a finite collection of n functions f of I for r from r squared to r squared. The solution of the system is the set S in r squared, and hence an image. That is the fixed point of Hutchinson recursive set equation. So that's, my color is probably white for some reason. Yeah, let's change that to black. Well, let's actually change it to like pink or something. Magenta, there we go. So that's the Hutchinson operator. If you go to the algorithm archive right now, you'll see we have a chapter on iterative function systems that say the same thing. Okay. The thing that's confusing me is down here. As implemented and popularized by Barnsley, the functions f of I are linear. Technically, they are affine, as each is a 2x3 matrix capable of expressing scale, rotation, translation, and shear. So here's what's not in the algorithm archive. The way that they specify their functions here is not just f of x, y. What they say is that f of x, y, right? Let me just try to do a box in here because I'm not doing a very good box. Okay. They say that f of x, y is actually going to read in a point, and then it's going to return a point that, and this is what I'm actually not doing a very good job of. So it's going to return a new point that is somehow changed. So let's see, for example, if the functions are f0, f1, and f2, and this is going to be, this is going to be for the Sierpinski triangle, they're going to say that f naught is going to be x over 2, y over 2. F1 is going to be x plus 1 over 2, y over 2. I see. Okay, so all they're saying is that each individual function, so this is actually a set of functions. So f naught is actually going to do something to x and something to y. And this is going to do something to x and something to y, although I don't understand why it's x plus 1 over 2 exactly. I guess it's because they're offsetting it or something like that. And this is going to be y plus 1. So, okay, I see what they're doing. So it's going to be, this is going to be 0, 0. This is going to be plus 1 and x, and this... No, that's not what they're doing. This is 0, 0. This is... No. This is 0, 0. It's minus 1 in x, plus 1 in y. That has to be it. Yeah, okay. So in that case, they have a different set of functions. The way that they're specifying functions here is a bit weird. So we're going to have to kind of think about how we interpret what they have written in this paper to our code base, which is going to be slightly different, right? Although it's Python 3 syntax, that might get compiled to Python 2.7. Interesting. Yep, the vertices are 0, 0, 1, 0, and 0, 1. Right, but the thing is, this function doesn't make any sense to me, right? It's saying f naught is going to be equal to x over 2, y over 2. Okay, so what does that mean then? That means that your point A here is going to be at point 0, 0. Okay, that's what they're saying. Yeah. Then your point B up here is going to be at 1, 0, 1. And then your point C over here is going to be at 1, 0. That's all they're saying. It's just the way that they've this written, it's kind of opaque, right? That's the thing. Yeah, it's rotated or something like that, I guess. Hey, Trash Talk, how are you? I'm trying to pan out the rest of my bachelor's. Any help? Yeah, feel free to ask either here or on Discord. I don't know if I can, like, I might not be the best person to ask, but I might be able to help a little bit. Donker5, thank you so much for following. Really appreciate it. You flipped A and C, but yeah. Maybe I did. Yeah, could have been. But that's essentially the point. I flipped A and C? Wait, what do you mean I flipped A and C? I don't think I flipped A and C. Like their whole triangle here. This image is not the image from these functions. That's the wrong. That's wrong. Sierpinski's gasket is Sierpinski's gasket, a simple iterative function system. X. What? Capital X, lowercase y, increase towards the lower right. Right. Increase towards the lower right. Okay. The recursive structure is visible as the whole image is made up of 3 copies of itself. Whatever. Okay, no, that doesn't make any sense. Now I have to think about it. Their set of functions is x plus 1 over 2, right? The only way that's possible, that their function here is x plus 1 over 2 and y over 2, is if we have this set of points. B is 0, 1, C is 1, 0, and A is 0, 0. A, 1, 1, and 0 is the top left. The figure makes absolutely no sense. Yeah, this whole thing is dumb. Like, this doesn't make any sense. That's okay. We'll just ignore it, and we'll keep going. Because this set of functions would create a fundamentally different triangle than they have up here. But whatever. Okay, we're kind of splitting hairs here. Okay. That is the thing. This did go through peer review, right? Like, how did people not pick that up? But anyway, fine, whatever. That was the only thing I wanted to point out there. The next thing is we need to start talking about the different variations. So this is what kind of caught me up last time, because I wasn't sure how to generalize their set of variations to our like function set, right? Because they're using a slightly different notation. Okay, so then they say now we generalize this algorithm. The first step is to use a larger class of functions than just affine transformations or affine functions. Start by composing a nonlinear function vj from r squared to r squared with the affine functions this. Okay. So essentially, any variation, we can do any variation, right? Appendix A gives you 49 different variations. Here's a couple sets of them. R is x squared plus y squared. All of that's fine. PDJ is a specific variation. And then what they basically say is variations can be further generalized by replacing the integer parameter j with a blending vector v of ij with one coefficient per variation. Okay. So they first do an affine and then a weird function. That's the thing, right? So that's the thing I'm trying to figure out here, because it seems to me that the way that they've written this here, right? So they have a pre-transformation. This is what I can't quite figure out. In my opinion, they don't have a pre-transformation. They just have a post-transformation. But when other people have read this paper, they see that there's both a pre and a post-transformation. So because of the way they've notated this function up here, it seems to me that their variables, this, they're two sets of variables. Let me change my color to blue or red or something. Blue, sure. They're two sets of variables, this guy and this guy. So those two guys are their function definitions, I suppose. Yeah, this is what I'm trying to figure out. But obviously, they have a bunch of variations, and these variations are added together with some sort of weight, right? So you'll do a little bit of swirl and a little bit of heart or something like that. If these are your two variations, swirl and heart, then you'll do like 0.5% swirl, 0.5% heart or something like that. That's totally fine. But what I can't quite figure out is, yeah, it seems to me like they don't. Can I search? I don't know if I can. Pre? Yeah, okay. That's because I'm using it dumb. Right, so again, this is one of those things that I can't quite figure out because I'm not sure if it does. Yeah. So they first do an affine and then a weird function. Right. I think it's just a weird function. That's what I think. As implemented and popularized by Barnsley, these functions f of I are linear. Technically, they're affine, as each is a 2x3 matrix capable of expressing scale, rotation, and translation. Okay. Let's see. Yeah, that's the thing. I can't pronounce affine correctly. Like, every time I try to pronounce it, it's wrong. It just sounds wrong. Affine sounds wrong. But I guess that is how it's technically pronounced. It just sounds wrong. There's an affine transformation on an affine transformation, and then you can do what you want. Affine sounds right. Yeah, I don't know. I think it sounds wrong, but whatever. Doesn't really matter. Okay. So, but also I've never actually heard the word pronounced by anyone, right? Like, that's the thing. The only time I've ever heard it is like when I've read it, so I'm the only one that I've ever heard pronounce that word. Therefore, I don't know how it's actually supposed to be meant to be pronounced, right? I just heard a lot in my GC class. What are you actually doing? We're implementing a fractal flame method. I think that's what it says. Yeah, fractal fires. Okay. Anyway, we're implementing a method to generate essentially, weird fractal shapes like, Sierpinski triangle and stuff like that. So, computer graphics. Yeah, that's fair enough. Okay. So what Amaris is saying is there's an affine transformation on an affine transformation, and then you can do whatever you want. Right. So that was what I was trying to figure out. Is it an affine transformation into a space that you can then do whatever function you want, and then an affine transformation out? That wasn't my understanding of this before. And again, we've done multiple of these before, CropUp. This isn't our first rodeo. We've done like hundreds of these before. So anyway, let's just go ahead and let's see. What do we want to try? We have. I promise you we have. Foldster has a collection of like 100 of them. I myself have done at least I've done at least 100 of them, definitely. So swirl, we've done swirl before. We've done them all before. We just have to re-implement them. So I'm not really, we'll get there, but we need to get there and make sure we're doing this right. Where's the fractal fire? It's called the fractal flame method, so that's why I called it the fractal fire. Let me get some water. And yeah, I guess we'll just keep going. Oh shoot, I have to do one thing over here. Really sorry about that. What, you don't think so? Wait, actually, now I don't know what you're talking about. I'm sorry about that. 1 second, guys. Sorry. Okay. Sorry, I'm kind of expecting a call today, so if that call comes in, I might have to close stream prematurely. Um, so I had to log into some things over here so we could check to see if that would happen. Sorry about that. Again, it's not that, it is what it is. VJ is not always a fiend. Right. That's the thing, right? So, okay. You were asking whether there is also an affine transformation after V. Yeah, so there definitely is. Right, so that's the post transformation. At this point, applying a transformation to a set of coordinates involves first applying an affine transformation to the coordinates and then applying a nonlinear variation function to the result of the affine transformation. We further generalize this. Okay, it reads it just there. To this point, applying a transform to a set of coordinates involves first applying an affine transformation to the coordinates and then applying nonlinear variation function to the result of the affine transformation. Okay, it says it right there. So you do an affine transformation before applying a variation. Now, I'm not really sure what that transformation is exactly because it doesn't really state it. But I guess it can be anything, right? So I guess we'll just go ahead and hop in and start with that, right? We'll implement some sort of affine transformation and go from there. So let's just cd. Actually, we're already there. So L is here. And let me think about this. So L is into source. And what do we have? We've got all the different flame structs, the fractal flame method, the image tool is something like that. So what am I going to do? I think what I want to do is I want to create a new file, source, and we'll call it transformations.jl. Okay. And I suppose here we'll have, so this is what I'm not really sure about. We probably need a set of affine transformations, right? And I suppose this can be anything. So now I'm trying to think, what exactly, do we just implement all of the different transformations, like scale operations, rotation, all this kind of stuff? I guess, wait, is it just scale and rotation? Maybe that's the only ones that we have. What other, I guess, translation as well. So we'll think about that. Shear as well. Oh yeah, shear, yeah. Hello Shadron, how are you? Translation is not, how is that not affine? I thought affine was the same. Wait, what? I thought that was anything that maintains the parallelism. In affine transformations, any transformation that preserves collinearity. Right, yeah, so technically it is. But also, like, the question is, do we actually care about that? And I don't really know. So do we implement them all separately, or, okay, I think we found our answer. There seems to be, like, there's probably some sort of mapping that we can do here, right? It's not linear, but affine. Wait, you're saying that translation is not linear? Wait, how is translation not linear? Sorry about that. I don't fully understand that. Maybe I'm... No, I don't fully understand how it's not linear. Sorry about that. I guess, what's the definition of linear in this case? Yeah, okay, maybe it's up here. Well, okay, let's just say linear. Right, linear keeps the origin. Oh, I did not know that. Okay, that's fair enough. Function is linear if and only if it preserves a linear structure. That doesn't help me because obviously translation keeps a linear structure. I don't know why the definition is that it keeps its origin, right? So, okay, so that's my question, right? Like, if you move something, I don't understand how that's not linear. I'm still, like, I understand if the definition of linear is that it keeps the origin. Fine, that's the definition. But it's weird to me that, I just have a question. Why do you work Julia most of the time? It's just easier for a lot of debugging, or it's just easier to write code in Julia, and it's fast. If you change the origin, it changes the vector. If you change the origin, it changes the vector. Yeah, well, okay, so it changes the vector by an offset, right? But then how does, I mean, rotation also changes the vector. Every other operation changes the vector, right? So I guess my question is, why is rotation okay? Okay, Maybe linear. What is the definition of linear? Am I just not understanding the definition of linear? Arranged or extended along straight lines. No, yeah, everything's still linear. And progressing from one stage to another in a single series of steps, sequential. Yeah. So okay, I mean the lines are still linear. If you move them around, they're still linear, right? So okay, I know I'm squabbling over like little. This doesn't matter. If the definition of linear, if the definition here is that we keep the origin, it keeps the linear combinations. Linear means it keeps linear combinations. I still don't understand how translation doesn't keep linear combinations. Okay, let me Google linear combinations. I'm sorry about this. Is an expression constructed from a set of terms by multiplying each term by a constant and adding the results. Linear sometimes is defined for an operator. Right. Suppose that K, linear means f of a plus b is equal to f of a plus... okay, that's fair. That's what I forgot. Sorry about that. You're right. Right. Yeah, I gotcha. That's fair enough. F of ax plus by is a f of x plus b. Yeah, I gotcha. Okay, let's just keep going then. So is there a general affine map that we can do here? That's my question. Or is it all going to be... So it's going to be rotation. We basically just need variations of rotation and shear and scale, right? But I think that can all be done in one matrix, right? I don't think we need... I mean, we could have helper functions for rotate and shear and stuff like that, but I'm almost positive this can all be just done with one, like, affine matrix or something like that. Linear operator is an operator that is defined over a vector space, so... Yeah, so that also doesn't help me. I'm so sorry, like, that... I'm sorry, maybe my linear algebra classes were just crap. Like, honestly, my linear algebra class in university was absolute garbage. And my linear algebra class in high school was fine, but also it was high school, you know? So that doesn't really help very much, right? Anyway, and what I'm learning now is that a lot of people don't have linear algebra classes in high school. I only learned that this semester. I thought most people did have some sort of linear algebra in high school. I suppose, again, if we just have some sort of a fine map, that's fine. The matrix is on the screen at the moment. Yeah, I mean, you can essentially have A as anything, right? Like, it doesn't really matter. I think as long as A is, like, just multiplying, I think it's okay. So let me see what I did in my other code base over here. So I'm going to open this up, and we're going to go over here, make this huge, move that over there, and move this over here. Let's see, people usually have analytical geometry in high school and linear algebra in college, as far as I know. That's probably true, but linear algebra, like, it wasn't something that I had to take, right? It was something I did take, but it wasn't part of the curriculum, right? So I didn't technically have to take it, which might have been another reason why I didn't focus on it so much. Anyway, let's go ahead and cd projects simuleos fractal L is here vi ifs, and let's go to the affine function and see what I did here. So I basically had point and values. Okay, this is a pretty dumb way to do this. Oh, okay, I see what I was trying to do. Right, so the code had broken to the point that I couldn't figure out what they were trying to do in the paper. And so what I did is I just said, screw it. Let's have them define alpha, beta, gamma, delta, eta, and zeta. Let's have them do that. And then we just do this. You know, so I was saying, you know, they can define these terms, alpha, beta, gamma, delta, eta, and zeta. And yeah, we just do the transformation that way, which I suppose is fine, but actually there's probably a better way to do that. Vector space is a set where every linear combination of elements is always an element of the set. LA is legit the most important class I ever took. Use it on a daily basis. Yeah, I use it every day as well, right? Also, you need to define it over a field, but whatever. Epsilon. Oh, yeah, you're right. It is epsilon. 8 is a big N one. Sorry. Okay. So let me think then. So if that's how I implemented it before, I think probably I don't want to implement it that way this time. I think the only reason I did it that way before was because, again, I was trying to figure out what they were doing, and doing things the way that doing the way the texts told me to do it did not work. And so I had to do it in another way, so I kept trying different ways, which is why this code's completely broken. So part of the reason, again, we've done a lot of fractal flames in the past, but I'm not convinced any of those fractal flames actually worked, because I'm not convinced that, I've read through this paper a bunch, and we've implemented it like 5 or 6 times. And every time we get a different answer, because of different, ways in which we interpret the paper. I don't know. It's weird. I don't really like it that much. Okay. So what are we actually going to do here? So, let's see, what do we have? So the linear map is just x and y. The sinusoidal map is sine x, sine y. The spherical one is 1 over r squared times x, y. And then we have, swirl, all this kind of stuff. How did I do swirl before? So before I did swirl as, I think literally what it says. And then we have a point color. Yeah, okay, this is what I did before. So obviously we can implement all these functions similarly to how we did before. So that's not going to be an issue. What will be an issue is the affine transformation. So what do we have here? We have some sort of function is going to be equal to ax plus by plus c, right? So what is a for our transformation? So a here is going to be, is ax plus b, but y is equal to f of x is equal to ax plus b. Y is up here. So why is a here? I need to think about this. So are they saying that any affine transformation, any affine map? All right, I've already asked help from a qualified person. Okay, that's fair, trash talk. I understand that I'm not qualified. Okay. So here's different affine matrices. Right, okay, this is fine. It's just a 3x3 matrix. Now, how is that actually multiplied by the set of functions? So this is going to be the identity matrix. Obviously, that's translation. So what does this mean? It just means that this is reflection. How are we multiplying this? I'm sorry. So what is the 3x3 matrix? What do each of these terms mean? So it's going to be a 3x3 matrix, but we have. So does this mean how does A multiply this? So a 3x3 by a 3x1 will give you a 3x1. Okay, that's what you want then. It's literally just multiplication, and that's fine. I'm not implying that you're unqualified, although you kind of are. Jeez. Fair enough, I guess. I mean, it's not like I've got a PhD and all this kind of stuff, but I guess, yeah, I'm unqualified. That's fair. But you're right, I am unqualified, probably. So yeah, that's what we want then. So we can just do any matrix multiplication. So any 3x3 matrix should work here. I mean, you don't know me personally. That's true as well. It's ABC times DEF from the paper. Wait, then what's the last row for? You can ignore why? Okay, then what's the last row for? Yeah, okay, what is the last row for? What's the point? Why are they defining, why are these 3x3 matrices if then they're not 3x3 matrices. Why is the only reason they have it as a 3x3 matrix so that they can, because they're ignoring translation. That's why. Right. The third row is only translation. Yeah. Or the third column is. The last row of the 4x4? The last row of 4x4. It's the homogeneous coordinate. I don't know what that means. Sorry about that. Third column is translation. Yeah, third column is what I meant, not third row. Third row is, you're saying is a homogeneous coordinate. What does that mean? Sorry about that. Let me get some more water. Um, the person making the graphics probably couldn't be bothered making it 3D. You always have to keep 1 in the last part of the vector. It's something we do to allow translation. Right, I can imagine that. Yeah, you need it to allow translation. And that's fine, if that's what you want. But why is it called homogeneous? What is a homo? I'll Google that. Your vector is xy1. I don't know where the name comes from. So in mathematics, a homogeneous coordinate or projective coordinates introduced by August whatever Mobius are a system of coordinates used in projective geometry. As Cartesian coordinates are used in Euclidean geometry, they have the advantage that the coordinates of points, including points at infinity, can be represented using finite coordinates. It's something used for translation if affine, or perspective if projective. Right, so that's the thing. What does projective mean? So what is a projective geometry? Is this back to the whole, like, is this like when you project things from one dimension to another dimension? That's totally fine if that's what this is. But this is a bit different than what I was anticipating it being. So like usually if you're going to go from like 4D to 3D, for example, you're going to multiply by a 4x3 matrix so that you can move it down to 3D. So it's a 4x1 vector, which is then going to multiply by a 4x3 matrix so you can get a 3x1 vector out. Basically 2 points x1, y1, and z1. And x1, y2, and z2 are equal if they are collinear. You don't use that for affine. That's fine, but I need to know what it is, right? I mean, why are you specifying elements in a matrix if you don't care about those elements in a matrix, right? Like, that seems like a dumb thing to do. Hey, Loca Padre, how are you? So then you said something up here, Crappie. Your vector is x, y, 1. So what is the 1? I don't know where the name comes from, but it's something used for translation, perspective, or projective. You need for translation in this case. Okay, but yeah, because translation, okay, so, right, if you have ax plus b by y plus c, right? This is really hard to explain. I'm sorry about that. I know I'm asking really stupid questions. But honestly, like, I'm not remembering any of this, like, from that. You need the matrix to be square. Right, like, if that's what it is, you're literally just specifying elements because you need the matrix to be square and 3x3, so you can do the matrix multiplication. Fine. That's fine. I do understand this. You have to multiply 3x3 by 3x1 to get a 3x1 matrix out. And the 3x1 matrix has to correspond to that. So I totally get that, right? Is it geometric algebra, I think? Oh, that's probably fair. So I do understand that you need some sort of 3x3 matrix. If you have a 3x1 coordinate system, which is your x, y, and then random constant. But now, what is c in this case? Is c... Okay, yeah, so it's obviously slope in x, slope in y, and then c is going to be your offset, right? So that's why I thought the last row would stand for... Yeah, c should be a translation, but now I'm questioning what's that translation in? Oh, that's going to be a translation. Yeah, it's going to be some translation. It's fine. Doesn't matter. So I'm just going to say a, b, c. Well, okay, let's use different variables. D, E, F, G, H, I, K, L, M. A, B, C, D, E, F, G, H, I, J. I missed J. You kidding me? J, K, L. There we go. I don't know what I wrote, but... Okay, so here's my understanding right now. If you're going to do a rotation matrix, you only need these guys right here, right? Because it's going to be your rotation matrix. It's going to be like sine of theta, blah, blah, cosine theta, right? So these guys must deal with your slopes, right? This has to deal with your third coordinate c, but also doesn't this one deal with your third coordinate c? So like that's how this row must stand for translation, right? So what's that bottom row then? That's what I'm trying to figure out. Probably algebraic geometry, because f of x is equal to ax plus b, but you can make it into f of x is equal to ab plus x times x semicolon 1, MATLAB notation. Don't know MATLAB notation. Let's see. If the f is translation of x, I don't know. I don't know. I haven't used it much yet. JKL. It's always 0, 0, 1. All right. Basically, you have a point x, y, z, and your homogenized affine map is f prime is ax plus by plus cz. Purple is rotation, scale, and shear. I probably should have done these in different colors. Okay, let me do this in different colors really quick. So we're gonna say, yeah. So you're right. This guy here is your slope. So it is rotation, scale, and shear. I think all of that is in this box here. This right here is what you use for translation. Right. So that's gonna be this guy over here. So it's not projective. Right. So that's the question. What do you mean what do you mean we're not projective? Okay, my stream is lagging. Sorry about that, crop out. No, it's okay. I think I understand exactly what you're trying to say. So now this is a row that I'm confused on, and now I know what you're saying. It's always 0, 0, 1, and that's fine. Yeah, but you know, it has to do something. Should we just like because these are 3D, it's kind of a pain, right? I was thinking because I mean if they're 2D, this isn't a problem, right? It's the projective coordinates. Okay, so projecting from 3D to 2D then. F is translation. F and I are translation. And the projective scale. Also, it's also part of the translation part. And the projective scale. Okay, right, so I guess what you're saying is, if we ignore this bottom row, this is going to be a 2 by 3 matrix, right? Which means that if you multiply 2 by 3, if you multiply 2 by 3 by a 3 by 1, you get a 2 by 1. We want identity in Z because we're projecting onto a 2D plane, is my understanding. So that's why it has to be 0, 0, 1. But again, if that's what we're doing here, that's fine. Okay, that's fine. That's fine. It makes the third coordinate always remain 0, 0, 1. Yeah, right. I get that. Yeah, okay. So it basically means that the third coordinate is not changing any. So what we're saying is by doing affine maps, we really don't... So, like, by doing affine maps, we don't really need these guys at all, right? They're just always going to stay 0, 0, 1. These should have the projective scale. Right. Which defines where the near and far plane is at that point and how it projects. Okay. I think I'm understanding what you guys are saying, right? Because we're projected onto a 2D plane. Is it allowed? Yeah, please feel free to put a link in the chat. So because we're projecting specifically onto a 2D plane, really, and we're doing affine transformations, that means that we don't really need to translate. And because we're 2D, we're not going to need this third thing because it's always going to be projected onto 2D. There's no reason to move into 3D. And this guy up here is the only thing that we really need to modify, which does your scale, all this kind of stuff. Affine can have translation. Yeah, okay, right, but we didn't want linear, right? That was the issue. I was wrong before, I was confused with linear. Right, but I think they oh, they do have linear. Is it any affine transformation? Or I thought they needed affine linear. Start by composing a nonlinear function. Okay. Fair enough. I understand what they're saying now. Okay, so we do allow for translation then. Gotcha. Okay, we do allow for translation. Fine. If you ignore the third column and row, you have the underlying linear map, not the affine map. But again, it's relevant here. I was wrong before, I was confused with linear. Linear is a subset of affine. If you ignore the third column and row, you have the underlying linear map and not the affine map. Right, yeah, I understand that. Maybe I need to just do the multiplication and just like check with things. But the problem is I can't really do that with the plotting tools I have in Julia, right? Because essentially this is the function for a plane, essentially, right? So what we're looking for, I feel like Is this something that, okay, let me ask you. So obviously, Psycode and Crophead here know what we're talking about. So does Amaras. People here know what we're talking about. I'm gonna ask you guys, do you feel like this stuff was adequately explained in your linear algebra classes, or whatever class it was that you guys took for this? Maybe it was someone said something geometry. Or do you feel like this is something that we should spend some more time with, specifically so that we can explain? Yeah, that's what I'm thinking as well. I learned it way later. I think maybe it's worth spending some time, maybe not now, but in the future, doing some visualizations of this. Because honestly, just this up here, even though I know it's incomplete and I know we're not quite done with it, specifying like what this is that we're looking at is really important. So I think I actually want to maybe do a video on that. Just what is an affine transformation, and we actually talk about it. And we just say, this is what we're talking about here. Let me grab my notebook really quick and write that down, because I do think that's something that we should do. I feel like it's something we should definitely do. But again, maybe not now. Let's do the fractal flame stuff now, not worry about it too much. But this is confusing enough to me that I feel like I want to devote time to understanding it. So give me just a second. Let me just to grab my notebook and write this down. I think this is what we're talking about. I just highlighted. I'm really bad at this. Here. Yeah, okay, I think this is about what we're looking for. So again, see, that's the thing. Always 001 on that last row. And 001 on the... Okay, right, because they're doing... Translation is going to be XY. Fine, fair enough. So what happens with the... Why is it always 001? But yeah, this is exactly what I was looking for. Right. So again, I understand maybe it's just 001 to make the multiplication work out, which is fine, but that's a very unsatisfying answer, isn't it? I didn't know linear algebra until university. I'd already learned it at age 16, 17 in high school. Yeah, that's the thing too. Like I learned linear algebra in high school, and I remember maybe vaguely doing some of this stuff in high school, but not, it's been such a long time, I don't remember it. And I definitely didn't do this in my linear algebra class in high school, or in university. Okay, I'm just gonna write this down, and then we should be good to go, and then we can keep working on the fractal flame stuff. So set of affine transformations. One second. How's the matrix? Okay, I think that might be worth talking about. I agree with that, Crophead. That's what I wanted to do. I wanted to visualize this as a set of planes. Actually, let me make sure I write that down. Visualize as a set of plane. Visualize as planes. And do all mults. Because that's the thing that I need. I just need to do all the multiplications and explain why, like, literally all these affine transformations are 001 in that last row. That's the thing I want to explain. Fair enough. Okay. Cool. So that was good. Thanks for that, guys. I do appreciate... I think that was a good conversation. I really appreciate it. Okay. To answer all your questions, the top 2x2 matrix represents pure linear transformations, I assume. The 3x2 is affine transformations. One way to visualize that is our plane is 1. The 3x3 is projective transformation. Okay, that's fair. It's just when you think of projective transformations like 3D into 2D, what you actually want is you're going to want a 3x2 matrix, right? So that's where it gets kind of a bit confusing for me, because usually when you do projective stuff, you want to specify the dimension of the array that you're multiplying with to make it so you get out a vector of the appropriate size, right? So if this was, for example, 2 by 1, then we get out a 2 by 1 vector over here, and then that's like, that's 2D to 1D, right? The projective scale we call. Okay, that's fair. The same happens for a computer graphics when there comes a fourth row column, right? Because the projective is going to be represented in Z as it's the perspective scale. that we call. He's going to divide xy by z value. If you end up adding 1 to the end of the vector, so the matrix can apply offsets no matter what the original vector. Okay, that's fair as well. Okay. Oh man, my cords got all wrapped up. Okay, great. So that was a very productive conversation. I think that's about where we want to leave it, talking about affine transformations and stuff like that. And let's just write something that does it in code. And I think what I'm going to do, I think I will have a bunch of helper functions here. Well, I guess it doesn't really matter too much. Oh, what am I doing? One second. I don't think it really matters too much. So let's go back to our code here that I called transformations.jl. And in actuality, I think, okay. I need to think about how they want to do this. Write down a homogeneous coordinate. Yeah, I can do that as well. One second. I'll be back in just a second. Okay, I wrote that down, and I think we can keep going. So how do I actually want to implement this in code? I mean, we know that this is essentially the first 6 elements of our, of that matrix, right? So maybe that's what we do. We allow for, okay, so in general, we know that we're going to have an affine transformation. They're called NURBs too. Oh, okay, so NURBs I know that one. So maybe this is something that we can talk about later. But right, I don't think we really need a function like this. So function, oops, sorry about that. Function affine. I don't think we need like a and then point, right? I don't think we need this end here. Oh, maybe we do. Yeah, okay, maybe we do. So then we're going to say vector. So we want to return a new point. It's going to be point, and we're going to have an XY location. So we're going to say, I think it's XY in color. So XY color, which is going to be point.color. And in here, I'm just going to actually change this to P and change the type here to point because, you know, why not? And then in here, we're going to say, vector location. Yeah, we'll just say location is going to be equal to p.x and p.y. And then we should be able to do, so then the z coordinate's just 0, right? Does that mean the z coordinate is 0? I guess that's what we're going to have to do. The z coordinate here is going to be 0. And then we're going to say A. So the new location, I guess this is going to be, it should just be A times that, I believe. Because A is going to be a 3 by 3 matrix multiplied by this. And then we get a new location. And this new location should have, can't we just do location 1, location 2? I need to think about this really quick. Okay. So like, for example, if we do rotation, anything that's, right. So what they want us to output for the new location is A of I, they want this as the new location. A of X, B of Y, C is something like that. Why don't I just return location? Sorry, because we need to return point struct, right? Just because we're going to need the point for later, for like color and stuff like that. So, and all it is basically location is just X, Y, and color. But it's just a bit easier if we have them all in the struct. We're going to use it for other stuff later on. So, is that right? Is that actually correct? Let's just mess around with it in Julia really quick. Just because at this point I'm kind of a bit confused. So we're going to do Julia, and let's just create a vector that's, or a point location 1, 2, okay? And we're going to say A is going to be equal to, for now it's just the identity matrix, I think I can just do identity of 3. 3, does that work? Using linear algebra. Okay, now let's try identity 3, 3. Identity not defined. Identity 3, maybe? 3, 3? How do I create an identity matrix in Julia? I don't know. Wait, it's I. That's the worst notation ever. Yeah, good thing they didn't use I. That, like, I hate that so much. I know, but it's like, why is it I? Like, under what? Why is it EYE? No, okay. Identity in Julia. It used to just be identity, capital I. Oh, interesting. It's just I. I see. Is that how you pronounce it? But yeah, it's like, yeah, it's just awful naming. I know why it's called that, but it, like, if you read that in code, you don't know it's immediately the identity matrix. Like, they've got a bunch of things like that in MATLAB. Let's see, what do we have here? ID is going to be equal to matrix I. Can I do that matrix? I 3, 3. Oh, this is so dumb. What are they doing here? ID 4 is equal to 1 times. What are they doing? I 4, 4. Does this work? How did that work? But mine didn't work. Oh, because it was a different type of parentheses. Fair enough. Whatever. So do they need the 1 times? No, they don't. And then we want 3 by 3. I guess the whole, like, matrix I 3, 3 is really weird. Fine, whatever. I don't really care that much. Okay. So we're going to do that. That's our identity matrix. I'm going to call it ID is equal to that. And now let's see. We have the point location. What did I call it before? I didn't call it anything. So we're going to say location is equal to that. Obviously, you can't multiply that by the identity matrix. So now if we do ID times location, yeah, we get 1, 2, 0. That's what you expect. Okay. So now let's do rotation. No. What are you saying? No. Comma 1? Why comma 1? That doesn't make any sense to me. The comma 1, the 1, that should be that's like your location in Z. So why do we need a comma 1 there? Sorry about that. 1, 2. Right, I understand that you're saying 1, 2, 1. My question is, why do we need a 1 there? Okay. So, let's see. Let's see. So what I want to do then is we want to have a rotation matrix in here. So what is the rotation matrix again? If you do a 4x4, you can do fancy linear algebra transformations. Yeah, I guess so, but also we don't need that. It's cosine, sine, sine, cosine. Okay, so we're going to do, I'm going to create a function, a rotation, sure, whatever, of some sort of theta, and return, and I guess I just want to do cosine of theta, sine theta, 0. Is that right? Oh, is it negative sign to start? It's probably negative sign to start. Sorry about that. Negative sign. Then it's going to be I thought negative sign was in the lower left. Oh, okay, never mind. Then it's sine theta, cosine theta. Oh, I missed a parentheses. And then should be 0. And then finally 0, 0. 0, 0, 1. That should be fine. And okay, so now if I just do rotation of 0.5, I guess. Okay, there. That's a fine rotation matrix. So we're going to say rot is going to be equal to rotation. And now let's see. Because we don't find transformation. If there's no one, the translation would not work. Yes, that's correct. Yeah, that is definitely correct. Okay. So then what? So, but you know, what that's saying, if we have just a 1, we're talking about the 2D projective plane. So yeah, it's a 3x3 matrix. I need to go AFK while you're. We're not talking 4x4 at all. Sorry about that. Okay. So what happens if we do rot times location? This is going to give us that. So if we say location is going to be equal to 1 to 1 again, and then we say rot times log. Okay. The thing here is though, I only want to output the. So let's give the rotation matrix of 3, I guess. That should be 0. Let's give it some sort of rotation or some sort of translation. Sorry, rot of 3 is going to be equal to 1. And now let's see what happens if we do rot times location. Yeah, see, that's what I thought. That doesn't do anything. So how do we bring that back to 2D then? The one in what Cropip is saying. Thanks. Okay, let's go here, paste that. The algorithm is to add one vector, is add a 1 to the vector applying matrix and throw the last value away. If you want the vector to be translatable, you need to set it as 1. If you do not need it, set it as 0. If A is only 2 rows, we don't need to drop the 1. If A is only 2 rows, we don't need to drop the 1. Right, that's fair. Because then it's just a 2x2 by a 2x2 times a 2x1 matrix, which is totally fine. This doesn't help Amaris at all. it doesn't help. I know this. If you just add 1, section 6.1. Okay, thanks. 6.1. Also doesn't help. This doesn't help at all. That we also know that. Like, that's not an issue. Okay, so this needs to represent a 2D vector as 3 by 3 vector x1 xy1, and similarly for higher dimensions. Using the system translation can be expressed with a matrix multiplication. It didn't do any translation though. Okay, so then how do you? Yeah, that didn't work. That didn't work at all. So we have the rotation here as that matrix. Oh, what? I set rotation of 3 is equal to 1. Oh, I see the problem. That wasn't what I thought would happen. Okay, now I understand. 0. And we actually want rotation of, whatever, 1 by 3 is equal to 1. Sure, that'll do. And now if we look at rotation. Sure, okay, now if we do rotation times location. Okay, that'll do. Yep, that's what I wanted to see, I think. Yep, that's exactly what I wanted to see. Perfect. Okay, thanks for that, guys. Sorry I'm being such an idiot. Okay, so we're going to control D out of there, open up transformations.jl, and we want this to be a 1. And then this should be a simple application, and that should work. Column versus row major, that's correct. Yeah, okay, gotcha. So that's why it didn't work before, because of the column versus row thing. So, okay, that should be fine. So now we can, if we just have any arbitrary A, we can multiply it by our point, and that's fine. This is fine. In principle, probably I should override, that's correct. Did you notice? Did I notice what? Sorry about that. You changed the last row? I changed the Z value? Yeah, Z value should stay 1. Yeah. No, I get it. Like, I understand why we don't specify it in this case, right? Because we're all in the one plane. Okay. So now we have, let's see. We have a fine here. That'll do for now. I don't think we have to worry about it too much. Okay, so let's do write and quit. Now let's go to VI source, and we're going to go into fractalflame.jl. And now let's go ahead and try to think about how we're going to do this. That's exactly what stupidity of programmer is proportional to the number of people looking over his shoulder. Well, then I'm pretty stupid. By the way, Jan Stranada, thank you so much for following. Really appreciate it. Good. Okay, I had to check to make sure I didn't get any notifications. Again, I am kind of expecting a call, so if I do get this call, I'm gonna have to close stream earlier. The stupidity of Twitch chat is not understanding humility. Kind of curious about what happened to ray tracing. Ray tracing is done for now. I'm just straight stupid. That's also fair. No, you're not. Let's just say apparent stupidity. Kind of curious. Okay, so what happened with ray tracing? I'll go ahead and show you guys here. Let me just go to youtube.com. And let's go to Julia programming language, and sure, whatever. I'll find it here. And then let's go to playlists. And there should be one on computational thinking somewhere in here. Here it is. It's the very first one. I just wasn't looking. Okay. And then then we go down here. So with ray tracing, we finished up. Here's just like the 3D ray tracing live coding in the playlist and everything. I'll go ahead and give it to you here. Okay, so as far as like what happened with ray tracing, essentially I finished it. I did everything that I wanted to do. I wasn't able to do it on stream because I just wasn't able to do it on stream, but you know, I did what I could. How many? Oh well, it is what it is. I'm not too worried about it. So we finished up ray tracing in 3D and did everything that we needed to do for the class, and that was that. I had to take 3 weeks off the stream while we did that, or while I did that. I really like the recent AI denoising and path tracing combos. I don't know anything about this. I'm sure it's pretty cool. I just don't know about it. Okay, so it seems interesting for video games. Oh, I'm sure it is. Ray tracing is super useful in video games. I just don't do games or gaming development and stuff like that. Speaking of which, I'm interested. Just polling you guys to see what you guys find interesting. And obviously I know that it's biased because we're on Twitch and you're watching a programming stream and all this kind of stuff, but I did want to say something. If you guys are interested in me doing game development, I did create or start writing a terminal game long time ago. And I do want to continue development of said terminal game. My question is that more or less interesting than doing like mathy stuff? Like, for example, doing affine transformation videos and stuff like this. Like I've got a whole bunch of like really interesting ideas and I'm trying to figure out if I really do want to go back to doing the terminal game, right? I want to know how to use OpenGL and Julia. I think there's a Julia OpenGL package that you can use. Gonna grab some coffee. Don't do too much. Oh man, we're not gonna do anything. Pretty sure. Okay, so we have this function for chaos game. I'm gonna now create a new function. And let me think about this. So it's gonna be, it might actually be, maybe, okay. So I'm gonna think about this, how we wanna do this, right? So maybe the first thing we're gonna do is, instead of rewriting the fractal flame method, we're going to take a step back and implement some flame functions, and then we're going to implement the fractal flame function after that. So vi source, and let's do flames.jl. Makes me remember about that time I wanted to make a text-based MMO. Look, the thing is, I love like ASCII graphics and everything, and so I've really wanted, like, I wanted to build like a really good, high quality, like story-driven terminal game. Oh man, I had so many ideas for it too. It was called Specterm, and the idea was that you are a specter, and your whole goal was to find a person in the real world, right? So, you know, you move through the real world, but you technically live on the spectral plane, right? So you have to go throughout the real world and pass back and forth between the real world and the spectral world. Oh, there were so many good plot twists and everything. It was just a really interesting, unique storyline that I've never seen ever done in like any other game. Like, it was actually a really cool story, I thought. Actually, okay, I'm motivated to do it again. The story was really cool. Like, that game was like, I'm not gonna lie, that was a really cool story for that game that I wanted to make. So I'm gonna go back to it. We have to finish that game. It's really cool. I think game development is nice. It has some other interesting problems like synchronization, collision detection. Oh, we're not doing any of that. It's an ASCII game. No ASCII graphics, just text. Isn't text ASCII? I vote for a talk on asymmetric numerical systems and modern compression. I'm sure some people would be interested in that. Asymmetric numerical systems. That is a good point. What do you mean? Okay, so let's go up here and let's implement a few basic functions. So the first function I'm going to implement is just going to be called linear. It's going to take in a point, and I think it's just going to end here, and it's just going to return point. That's it. Okay, the next function is going to be, I guess I want to call it swirl, right? Because we had swirl defined before. It's going to read in a point. End here, and let's keep going. Okay, so there are a couple things that we have to consider. So let's go up into the set of variations here. So we have swirl, which is going to say x is going to be sine of r squared minus cosine of r squared. Yeah, so we can just implement that as is. So the first thing we have to do is define r. So r is going to be equal to square root of point dot x squared plus point dot y squared. Now I know what you're thinking. Isn't the squaring operation slow? And I think you're right. So I think actually what I'm actually going to do here is point dot y. I don't know if it's actually slow in Julia or not, but like superstition wise, I'm definitely doing a multiplication here. Okay. And then down here we just return. I suppose it's just going to be point. And then we just read in the xy values. So the new xy value is going to be the new x value is going to be point dot x times sine of r times r. Oh, hello, come on, let's actually type correctly for once in your life. Okay, minus point dot y. I'm gonna have to rephrase these guys in just a second. Times cosine of r times r. Okay, so that's our x value. And let's go down here, and again, we're going to do something similar. So it's going to be point dot, where are we? Point dot x times cosine of r times r, minus point dot y times sine of r times r. And this is literally just a rotation matrix, and then point dot c. Okay, similar to what we did before, I'm going to actually modify these points so they're of type point and they're just p. Okay, maybe if I can spell, which obviously I cannot. Okay, let's go down here, do the same thing. All right, and let's just remove all of these guys. So dt dot. Sure. 1 second. And I think this should be our swirl function just fine. So now that we have the swirl function, this will be the first like real flame function that we have. So I'm just going to try to do it and see what happens. Now, there are some things in here that we have to kind of think about, like the popcorn kernel in here takes additional variables C and F, and we have to think about how we're going to read those variables in. In my opinion, we probably want to read them as an additional matrix A. And so then we have to think about how we're going to do all these function pointers and stuff like that. But we're going to get to that later. Let's just get swirl implemented and then go from there. And yeah, let's go ahead, catch up on chat. Entropy coding, pretty much. Yes, I mean, my game was just going to be people sending commands to a Discord bot. Oh, that sounds pretty cool, though. In my first job, I procrastinated by playing terminal graphics games. Some boss would think I was still programming. Because clearly playing, you know, what is it, Moon Buggy on the terminal. Yeah, this is definitely still working. Right? What is it, F, A to shoot? Oh, I've never actually gone very far in this game. I've considered like doing a live stream, like, I don't know, like a charity live stream, kind of like Desert Bus or something. I don't know. I assume this game goes on for a while, but I've never really gotten very far because at some point I just crash. But anyway, like, my point is, like, this definitely looks like I'm working, right? Like, anyone watching this would think that I'm working. I'm kind of into the game. Let's quit it, actually. Yep, I know, game over. Yep, go ahead. Jars. Nah, whatever. Control C. Control D. Good. I just quit. Okay, so we've got our first flame. Let's go into VI source and then fractal flame.jl. As long as you hear the keyboard sounds. Is that all you need to prove to people you're working? Oh, man, you guys really got me onto my game again. I'm really excited to make that game. Like, okay, so here's the thing, right? Like, I don't actually like playing games too much. I play them every now and again. But what I really like is like writing stories. And the nice thing about this game is it's a new medium to write a story in that I haven't written a story in before, right? Like I'm always used to like writing like actual text. But the game was interesting because it was like one of the few times I could actually um, just, I don't know, like express myself creatively in something that wasn't math, you know? Cropepsia, thank you so much. Have a wonderful evening. And yeah, get some sleep. Video games to me are one of the most expressive forms of art. I don't know if I agree with that because I personally feel okay. You can use a lot of math to do them. That's true. Okay, so I don't know if I agree with that statement. That video games are the most expressive form of art because it really depends on how you want to express yourself, right? Like I do agree. I do agree with you in saying that. Video games have writing. They have art, as in like drawings and animations and stuff like that, and they have the ability to interact with said art. So there's a lot of interactivity that you can do with games. But I do strongly feel that I can become more engrossed in a book than I can in a video game, right? And so I guess my point is that yeah, I think you're right that it combines a lot of really interesting areas of artistic expression. But I also feel like depending on who you are, you might find it not to be um like as how do I put this? Depending on who you are, it might not be as gripping as it could be to other people. Does that make sense? For instance, Witcher 3 is a work of art. Right. The thing is, I could never get into Witcher because I just don't like the graphical style, for example. You know, something like Gears of War is just something. Yeah. It really depends on the narrative of the game. That's true as well. But honestly, I have never played a game that has gripped me as much as books do. And that is a true statement that I'm going through my mind and like there have been games that I've been addicted to. Like I'm dangerously addicted to Guild Wars and the Guild Wars franchise. Digimon World games are all just amazing. But I've never been like gripped by them, you know? And I think it's because the medium, I just don't like the medium for storytelling. Anytime people try to tell a story through a game, I'm not gripped by said story. It's there, but compared to literature, it's nowhere there. It's kind of the same with movies for me. Movies kind of fall flat. They're not really interesting to me. But books really do carry emotional weight for me. And that's why I enjoy reading books for stories, whereas I don't really like watching movies and I don't really like playing video games for story-driven narratives. Now, I can appreciate a good work of art. Like if the movie is like particularly well like cinematically described, or it's like really good with like the animation is really good, then I like it a lot. Anyway, I'm kind of rambling now. I need to quit rambling so much. Is something like Gears of War is just something you should try. Outer Worlds, maybe, yeah, maybe. That's one game whose story I don't think I could really be told effectively without being a game. It's entirely an individual interpretation. Exactly. That's my point, right? Like, I'm not trying to sit here and be like, oh, wow, look at all you gamers. If only you understood how to read a good book. That's not what I'm saying. And please don't think that's what I'm saying, because it's definitely not. What I'm saying is that the game is, depending on how you use the medium, you can elicit different emotional responses for different people. Undertale, okay, I will give you Undertale. Undertale is actually really good. The Witcher 3 is kind of an interface between product and art, while things like Call of Duty is well known. Yeah, Outer Wilds, not Outer Worlds. Oh, okay. Sorry about that. But actually, no, I will give you Undertale. Undertale was, and still is genuinely, I think about Undertale every now and again, right? And not because of the mechanics, but because it was like the only game I've ever played that allowed me to play like I would normally play a game. Like it didn't force me to kill things. And I'm like, I would never kill something in real life. Like all of these, like me, if like playing Skyrim and Oblivion, like these games immediately pull me out of like my comfort zone, because like the games are about combat. I have to fight things. I have to shoot things. I have to hit things with swords. This is totally unrelatable to me. But Undertale, seeing as how it flipped that on its head and you could be a nice person in the game and it rewarded you for being a nice person, even though it was a little bit more difficult sometimes, that was really cool. And I really appreciated that, So I think, yeah, that's why I liked Undertale, right? Like I felt like I could, I could be me in that game, whereas I couldn't be me in a lot of other games. So maybe that's why. Maybe I just don't like games because I feel like when it comes to playing games, I never see myself expressed in those video games. So I'm gonna create a new function here that's just gonna be called flame, and we're gonna figure that out later. It's gonna take in n, which is gonna be the number of points. It's gonna be very loosely based off of the chaos game. I just want chaos game there because almost certainly we're gonna need, like, our flame function is going to break at some point, and we're going to have to check it with the chaos game function. I love the fact that Undertale is all about the choice, be it for the good or the bad ways. Yeah, I agree with that as well, but I just couldn't do it. I couldn't kill anything in Undertale. Right, like I've created multiple builds in Guild Wars where you never fight anyone. Like, you use amity and stuff like this, you use skills to make it so no one actually hurts anybody, and you go as far as you can without actually doing any damage, right? And like, I always play support characters. I always want to help. I hate being the person to actually deal damage to people, you know? And so, like, if you have a game and there's no support character for me to play, I can't relate to the game because it's just not me, you know? I believe there's a theory in art studies that anything can be art, nothing can never be art. That might be true. I'm not an art student, so don't quote me on that. I never started a genocide run in Undertale. It's just hard. It's hard to kill things. It's mean. Okay, I'm actually going to copy this exact function letter for letter right now. So here we're gonna have point is gonna be 0.00 for 1 to n. Now what we're gonna do that's slightly different here is we are actually going to do an affine transformation, and then we will. Now is this for? Okay. So, let me change this just to be the swirl function. Okay, this is just now going to be swirl. Okay, and in here, okay, this isn't going to work, is it? It just takes swirl a point, I believe, right now, and this will create a circle, I think, right? Wait, yeah, it should just create a circle or something. We'll see what happens. So that means we don't need this one. We don't need the triangle points defined, and we can just create the points. So here, if we go there, we have flame, and I should be able to open this up in Julia. Double dash project. Make sure everything compiles still. So now we're gonna do using revise, and then using flamify. Hopefully everything still precompiles, and then we're just gonna try running our flame function. That's it. Just try running our flame function. And then what it should create is just a circle. That's what I'm imagining, because all this is a rotation matrix. So if we run flame on 1,000, to maybe, I don't know, just run it. Undefined value, it's because it's flamify dot flame. Range is not defined. Okay, good point. Ranges are not defined. That's because I call this ranges. Let's go, see what happens. Oh man, today's been a day. Like, honestly, okay, the stream has been, we've been doing a bunch of things on stream, and I'm not gonna say today has been productive, but I am gonna say I think it's been an okay day, you know, as far as just doing things is concerned. Like, you know, it's been fun here, hanging out, streaming, this kind of stuff. So let's do Mirage check.png. Did I forget to write it to file? Oh, no. This just returns points. So points are going to be equal to that. And then I should have a write image. Yeah, that's what I'm looking for. Okay, so now I'm writing the image out. So actually, I want to put that down here. So instead of returning points, I'm going to make it so it doesn't return anything. And it literally just writes image. Image. And it's going to take in points, ranges, and then the image resolution. So we'll have the resolution in here. Okay. Resolution. And then I'm going to have the file name be file name here. And then we're going to have it in as an optional argument. Okay. So let's see what it looks like. So if we run Mirage, I'm expecting a circle. I got a blank image. That is very far from a circle. Oh, wait, is it blank? Or is there a single dot in the center? The world may never know. But actually, I will know because I'm just gonna... Sorry, you guys probably heard something. Sorry about that. Let's see, screenshot. 11, 12, 19. Is that still a dot? No, there's nothing there. It's just a black image. I thought it was something, but no, it's just a black image. All right, whatever. I just feel like there is a dot there, but it looks like it might just be my screen. Okay. Let's close this. Let's just close that. There was nothing there. That's okay. That's fine. The question is why there was nothing there, and I don't have an answer for you. So let me just try making this so it is a 10 by 10 image. Okay, and now we're gonna run mirage check.png, and I am 90% sure there's nothing there. Yeah, there's nothing there. Okay. Let's see. So why is there nothing there? So we tried swirl. Swirl takes in the point location as it was before. R is going to be defined as... What is R going to be defined as? R is going to be defined as x squared plus y squared. Square root of x squared plus y squared should be R. And that should be totally fine. Swirl should be working. I don't see any reason why it wouldn't be working. Is this because our point doesn't have a color associated with it? That might be why. In fact, I'm 90% sure that is why. Yeah, I think that's why. Yeah, I'm pretty sure that's why. Because I just realized we return a point with a color associated with it. But here, we have no color associated with this function. So let's just give it a color. So we're going to say swirl color. All right. And in here, we're going to define swirl color is going to be equal to RGB of red 101. Okay, so it's going to be pink. Sure. Okay, let's go over here and we're going to run, I think I'm going to run the last using Flamify, and then I'm going to run fflamify.flame, and now we're going to read in an image resolution of 1000, 1000, and that should output something. So now if we do the last mirage, check.png, we still see nothing. Did I forget to write it? Okay, let's try that again. And also let's remove check.png and let's run it. And now we're going to open it up. Okay, so we're definitely running it. We're defining swirl color. So all of the points should be pink. Let's just output stuff. Let's just, for the fun of it, let's just output things. So here we're going to say, oh, you there, X there, print line, and we're going to print line points of I dot X, points of I dot Y, and then points of I dot color. And I forgot some tabs. Let's add some tabs in there. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I feel like chat's gotten a little bit quiet. Again, that's not a big deal. I just, I'm just saying that if you wanted to say something, we have time. Flamify.flame. They're all zeros. And the color is pink, but the location is all zeros. So there's going to be a single pink dot. Ever work with quaternions? A little bit, but not so much. I mean, we did some 4D stuff for the YouTube channel not too long ago. In fact, my most popular video is Understanding 4D, the Tesseract. It's got like 3 or 4 million views or something like that. How many views does it have? I think it's like 3.6 million or something like that. But maybe it's changed. It is at 3.4 million. So Yeah, feel free, take a look if you want. Again, this will eventually, what we're doing here today will eventually end up on the YouTube channel, but I don't know how long it'll be. Okay, so they're all zeros, which says to me that, I don't know what it says to me. Okay, let's go into the flames and let's take a look at swirl. So we said R is going to be, how are they all zero? R is going to be p.x plus p.x. We're returning point. Let's, Okay, so now we went from drawing a Sierpinski triangle yesterday to hopefully just trying to draw a circle today. That's all we're trying to do, just draw a single circle. Man, how we have fallen from grace. If I recall correctly, quaternions are generalized in Clifford algebra. Far more intuitive to learn them that way. Oh, that might be interesting, actually. So I know that 3 Blue and Brown did an interesting video not too long ago on quaternions. Maybe it was a while ago, actually. I'm not really sure. Okay, so we have swirl color is going to be pink. It is being colored correctly. But all of these guys are returning... Let's just print line line R and see what happens. Oh ho! Oh no, never mind. I thought I figured it out, but I didn't. Let's just run this again and see what happens. So R is 0 in all cases. That is good to know. Okay, so why is R 0 in all cases? So here we're saying that the points 1.x. Let me just print line here because I think that's what's going on. I think for some reason. I think this whole fancy thing to define points 1.x, points 1.y just didn't work. So we're just going to define it this way. And you guys are just going to have to deal with the fact that I can't code in Julia. And yeah, that's just how it's going to have to be. Sorry about that, guys. So we're going to delete this and we're going to define them differently. So this is going to be equal to that. 0.5 times ranges should just be ranges of 1 and ranges of 2. Plus rand. I think just rand should do it. Okay, let's try that. Error. No method matching plus. Okay, no method matching plus. Float 64, an array of float 64. Okay, why do we have an array of float 64? Is that because we have a dot times ranges in here? It should be range, I see, ranges of 2 and ranges of 1. There we go, perfect. Immutable struct type point cannot be changed. Are we, okay, I see the problem. So now we're going to say, 1 second, points of 1 is going to be equal to a point of that, and now we're going to add some spaces in here. I'll catch up in chat just a second, guys. Sorry about that. That, and we're going to say, ooh, hello there. And then we're going to say points of 1 dot color. In fact, we can just do that and that. Okay. Boom, look at that. So now if we open up the image, we get not what I was expecting. But we'll try to figure that out. Cool. Okay. I never heard of Clifford algebra, but I do know quaternions. It's an interactive demo, and it's amazing. I know the video you're talking about. Oh yeah. For those that never saw it, highly recommend it. Yeah. So yeah, Grant. Okay, so Grant is definitely a friend of mine. I don't know how good of a friend we are. I consider him to be a decent friend, like pretty good friend. But like again, this is one of those things where like you never know like how close you are. I don't know why I'm talking about this. The point is, I'm friends with the guy. He's an amazing person. If you can, definitely check out his channel. His channel is 3 Blue and Brown. He's just an amazing guy. And I genuinely feel like everyone here who's watching my stream right now probably would very much enjoy his content as well. In fact, probably if you're here, you might know me specifically because of him, and that's fine as well. Okay. Grant is indeed amazing. Yeah, the guy's amazing. It's just he's just such a cool guy. Everyone I've met in the educational YouTube space is just amazing. And it's just They're cool people. That's all I can say. Okay, so here we have points. It's going to be equal to 0, 0. We initialize the first point. We go through everything. I think in here I'm just going to say initializing the first point. Okay, so now here's my question. Does this image that we created with the 4 little loop-de-loop things here, does that make sense? Is this what we expect to get from our swirl function? All we did is we took in a random point and we applied a rotation matrix to that point and the new point's location. That's all swirl does. So why are we going out? Why is this not a circle? It does x times. Yeah, it does x times r squared. Because r squared is the angle, and the angle changes depending on how far away you are from the origin. So let me modify the swirl function so that it always takes in the same theta. Right, quit. Let's go into VI. In fact, let's create a new swirl function. So VI source, fractal flames. 1 second, I can type, I promise. And we're gonna create a new swirl function. Here we're gonna do yank, 6 yank. Paste up here. Whatever, I missed the end. Okay, we're gonna call this rotate. And this is gonna take as an optional argument theta. And instead of having an r in here, we're just gonna have all these r times r's changed into thetas. And this one should create a circle. Okay, 1 second. And here we're gonna say theta is gonna be equal to 0.5. I think this will create a circle. Let's just see what happens. So let's go into VI fractal flame, source fractal flame. And now in here, we're gonna say, instead of swirl, we're gonna yank and paste in here, comment that out, and we're gonna say rotate, I think is what I called it. Okay, let's remove this print line, write this, go over here, and let's just run this. Okay, now we're gonna take a look at Mirage, and that created a single point. Oh, no, it didn't. What did this, how is that happening? Giving you a nickname, I'm gonna say you're probably interested in simulations. Yeah, so honestly, the YouTube channel is Laos OS, right? Which stands for a number of different things, like Laos operating system, Laos open source, you know, Laos OS, you know, whatever it stood for. The OS was like open source operating system, whatever. Laos was my pen name that I used to, when I used to write books when I was younger, I used to go by Laos. So I started using Laos as my online moniker as well. Now, Simulaos, along with Scribble Laos, are 2 additions to the Laos family. So we have Laos OS as a primary channel. Then we have Scribble Laos for writing, which no one has subscribed to because I only put a few videos up on there. And Simulaos for simulations. But most people cannot pronounce the name and they have no idea that Laos is a thing. So when they look at Simulaos, they say either Sim or Simule or Simule iOS. They never see the Laos in there, so it's kind of funny. I made a fun class sim. Let me know if you want to see it later. Yeah, feel free to send it to me. These are different simulations than the type of simulations that I typically am interested in. So usually when I do simulations, I think of them from a computational science perspective, which is completely different. So, like, I don't know. I mean, just for funsies. No, I appreciate. Yeah, send it to me. I think it's cool. Send it. I think you can send it to me on Discord. If you haven't already, feel free to join Discord. Here, I get what you're saying. Okay, so I don't know what's happening here, but it's different than what I thought would happen. So let's define. Let's run it again, and let's see what it was this time. So zooming in, yeah. Okay, this is not. I was expecting a circle, right? Because we have an X and Y location. We have an XY location. And essentially all we're doing is applying a rotation matrix, right? Or am I just completely off base? Let's take a look at rotation. A post in Discord in 10 minutes. Oh, yeah, because I'm sorry about that. We had some issues with trolling not too long ago. P.X. There should be a plus here, I believe. And this should also be a plus. Try this again, Flamify. And now let's do Mirage check.png. There we go. Look at that circle. Man, that is a circle. If I've ever seen a circle, which I have not, but if I had, I promise you that would be, that's a pretty good circle. Okay, well, not in this view, but like, it looked like a circle before. Let's increase the number of points. So it'll be 1,000 by 1,000, and we're gonna increase the number of points to 10,000. And now if we do mirage-check.png, we see a relatively visible circle. That's not bad at all. I'm relatively happy with that. Now, you might be asking, what was happening with that 100 by 100 image? That's actually very interesting. I just realized this. That is, okay, well here it's all filled in. But let me lower the number of pixels again. There's something really cool that just happened that I want to show if I can do it again, which I don't know if I can because I was using random numbers. That didn't work. Try it again with maybe 100 points? 100 points. You can't see it. Okay, so if you look here, note that there's like little gaps here. So we actually saw an application of the Moire effect just a second ago. Psycode, thank you so much for following. Didn't realize you weren't following already, but hey, thanks for that. This might also be an effect of Moire, but essentially before we saw that like we had a connected line here and a connected line here and a connected line there. That was actually really cool because it meant that we were rotating at a frequency that was kind of like exactly creating quarters in a way. So we weren't seeing the whole circle. I thought that was kind of cool. Okay, so let's take a look at our swirl function now. I'm sorry, that was kind of random. I don't know why I said that. Let's just keep going. And let's try the swirl function. Here, comment this out, write that. Now we're gonna do flamify, and let's do a look at mirage-check.png. This also creates a circle, which I should expect because R is always the same if you're on a circle. So rotate and swirl should do the same thing, and they do. So we'll keep rotate, but it's kind of superfluous at this point. So now what we're gonna do is we are going to implement a new function. This new function is going to be, it doesn't matter what, we're gonna use the heart function. Let's go in here. So we're gonna create a new function, which we're gonna call heart. And this is going to take in P, which is a point. And here we're going to modify so the swirl color just for now is going to be pure blue. Hello, pure blue. I'm like losing my mind over here. I just can't speak today. Okay, and now let's get that heart function. I think it's down back here somewhere. Cosine, popcorn, waves, grid, Julia. We got to use that one later. Diamond, hyperbolic, spiral, disk, heart. There we go. V7, right up here. So it should just be R times sine of theta times R minus cosine of theta to R. So similar to before, we're going to grab these guys in here and we're going to do yank for yank, paste it up here. We're going to define an R is going to be equal to square root of p dot x times p dot x plus p dot y times p dot y. Okay. The swirl color here obviously has to be pink. It's a heart, you know. Okay, and so we're going to return back this swirl function here, which is going to have two values for x and y. And this is going to be defined as heart color. Try that one again. Heart color, and this is going to be defined as heart color as well. Okay, so let's grab that r x and y value. So it's going to be r times sine of theta r, and then minus cosine of theta r. So that should just be a dot product. So you should be able to do r times sine of some sort of theta that we're reading in. So theta, unless we can define theta. Let me think about that. Is theta just going to be, I think we can define theta, times r. And then down here is going to be minus r times cosine of theta times r. Okay, and our theta in this case is going to be equal to a tan 2 of p dot x over p dot y. And actually, let me open up some older code over here and see what we did for theta. So heart. So we said theta is going to be a tan of 0.2.1, which I think is y over x. So a tan of y over x, I believe. Okay, so that should do it. So now we're going to go into fractal flame, and we're going to use the heart function instead of the swirl function. And then we're going to mix the two together. And we should have a very basic flame ready to go. Okay, so let's see what this does. Go over here, run flamify.flame, take a look at the image, increase the number of points a bit, check.png. Okay, that did not quite work. Try that one more time. Increase the number of points again. Okay, we're really not getting anything, are we? Why, though? We could... What happens if we combine swirl with heart? Does this do anything? Okay, swirl works, right? We had swirl working just a second ago. So if we do flamify and we do check.png, again, it's working, but is this because our image is so small? 1000 by 1000. And now if we do check.png, okay, we get kind of what we expected. So now let's try it with the heart function. Let's try that again, flamify, mirage check.png. This is just weird, isn't it? It's not, Let's check the heart function we had before and make sure that heart function is the same as the heart function we wrote this time. So let's do quit here, flames.p, whatever. Open up the other terminal. Open up the other terminal. There we go. So we have square root of 0.1 squared plus 0.2 squared, the return point. We have a tan of 0.2, 0.1. Maybe I have my x's and y's mixed up. So let's try fixing that really quick. X, y. I'm pretty sure I had them the right way though. Flamify, mirage check.png. This is not what I was expecting to see. So change that to y and x. Okay, so we're gonna do flamify, check.png. We don't see anything on the screen, which is not, not great. We do see some points. Maybe it's just like going off the map somehow. So let's do quit here, fractalflame.png or fractalflame.jl, and let's make it so the ranges are smaller, maybe. In fact, let's give it an initial point to start with. So we're gonna say points of 1. Points of 1 is gonna be equal to, 1 is gonna be equal to, equal to point of 0.5, 0.5. All right, and we're gonna comment this guy out really quick. Write that, go over here, flamify.whatever, check.png. We're seeing nothing. Well, let's try swirl again. Just make sure swirl is still working. Okay, flamify.flame, mirage check.png. We do have that working. So let's make it even closer to the origin. Let's make it at 0.1 and 0.1. This should create a pretty strong circle with the swirl function. Mirage check.png, we get a circle. Okay, so now let's try the heart again. The heart's failing, but that's okay. Flamify, mirage. Yeah, we're seeing nothing. I'm not exactly sure why. So let's do something else here. And let's go up here and say function set is going to be equal to, we'll call it fset maybe. It's going to be equal to, it's just going to be swirl and then heart. And then essentially what I want to do, I think we can do rand of, let's just do 1, 2, 3. Does this work? I guess. So now we want to do function. F is going to be equal to, I guess it's going to be rand of fset. Something like this. And then in here we should be able to say points of I is equal to this. F, dd. That is kind of lame, but let's just see what happens if we do that. So now we're going to do flamify and see what this does. Mirage check.png. It, not really sure if that's what it's supposed to look like or not. But we kind of have the framework down, so maybe that's where we kind of leave it for now. We get the framework in, and then we worry about fixing it later. That's just a circle. Yeah, okay, my guess is because the heart function is just not working. Let's go into flames.jl. Heart is going to be taken P point. It's going to get an R. It's going to get a theta. The heart color is going to be pink. Why was the circle pink? It should have been blue. Wait a minute. That's because down here, this color should be changed to 0. Okay, so now if we do flamify here and we do check.png. Okay, so now it's this weird kind of purple color. Okay, so let's go ahead and put a to-do in here. Actually, I'm just going to create VI notes. And just so we have something to look at. And here we're going to say the heart function does not seem to work. It's going to be number 1. Number 2, what am I going to say here? I need to properly implement find transforms before and after. Okay, so that's, I think, a decent place to stop for today. Let me go ahead and do git status and add this to the flamify directory. Git status here. Git add, actually, let's do vi.git ignore, and let's add a few more things here. So g notes, and also star.pdf, git status, git add dot git. One second, vi. I need to think about something really quick. So if I go into vi source flamify.jl, I never added transforms to this. So I don't understand how it was grabbing those functions before. Transforms.jl, I think is what I called it. Transformations.jl. Okay, write and quit. Try this one more time just to see what happens. I mean, that's an interesting effect, but it's not exactly what I wanted. That's okay. We'll try to figure it out. So now we're going to do, let's do git add dot, git status. Okay, git commit -m. Adding structure for fractal flame method. Yeah, sure, that'll do. Git push, origin development. Okay, that's a good place to stop for now. We're going to come back tomorrow and we will be working on different fractal flame functions, trying to get them all working one step at a time. There's still a lot left to do, but I'm relatively happy with the direction we've gone in today. So we'll come in back tomorrow and keep working on that. I think, let's go ahead and see who's live and who we want to raid at the end of stream. Let's see, today is Thursday, right? Okay, that's fine. Friday, Kit Boga will actually have Felicia Day on, so I thought maybe if they were live then and Felicia was on, we could raid them, but I think it's okay. Let's do, I feel like we should do, who do we want to raid at the end of stream? I have not raided Skylius in a long time. She's doing space stuff. We have Hello Mayuko doing Coding Cafe. We have Tayanui. Again, I don't know how to pronounce the name. They're doing some math. Or we're doing Insuladosaurus, who I'm not sure what they're doing, but she's really cool. Tiny is doing like keyboard caps and stuff like that. Let's see. How about we do Skylius? We haven't raided Skylius in a while. Just posted a sim. Thanks for that. So let's go ahead and start the raid on Skylius. And that is it for today, guys. Thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will be seeing you guys around next time for the next episode of Simuleos. Should be at 6 o'clock Eastern tomorrow when we continue working on the fractal flame method. Lots of stuff left to do. And yeah, if you guys have any questions or anything like that, just shoot them on Discord. And see you around tomorrow. Peace, guys.